All right, so we're supposed to solve this system and classify it as independent consistent, dependent consistent, or dependent inconsistent. And I don't think that last part should read dependent inconsistent, but all right, so independent consistent is where we have a singular intersection. That's the big deal. Singular intersection. That would be this guy. Dependent consistent is where you have two lines that happen to be the same. We actually have infinite intersections. Then we have dependent inconsistent. This would be two lines with the same slope, which means no solutions. So anyways, that's, prereq, know how to do this. There's lots of ways to do this particular one. What I'm going to do is I'm going to take the bottom equation, I'm going to multiply it by -2. I'm going to rewrite the top equation. The goal is to create two equations that are additive inverses of at least one variable. It's actually worth typing. There's some words in there. We multiply one or both equations by a number such that one pair of variables become additive inverses. This is the elimination technique. So anyways, if I multiply the bottom equation by the -2, I guess I would have -2x minus 10y, because I'm doing the distributive property, equal to a -26. And then I can just add down. Some teachers teach add or subtract. I just do addition. That's no x, looks like a -8y, and 10 plus a -26 is -16, so y is therefore 2. And then you can just plug it back into an equation. I see this equation right here. X plus 5 y's and y is 2 equals 13. 5 times 2 is 10. And 13 minus 10 is 3. So you'll notice that we have a single solution. At 3, 2 order pairs. So therefore we are independent consistent. Not a hard problem. Moving forward. Equations with variable raised to the understood first power represent lines, or at least are considered linear. There are three possible outcomes for the intersections. Describe these outcomes and draw. So we could have a singular intersection. We would classify that as consistent independent. We could have the same line intersect forever. I thought I changed colors there. So we could have an infinite number of intersections. And we would classify that as consistent dependent. I'm basically just redrawing what I drew in the last one, by the way. And lastly, we could have parallel lines. And we would classify that as just inconsistent. That's the big one. Inconsistent. No solutions. There you go. Another solve and classify. You can do these however you want, but I'm just going to multiply the top on this one by -2 and distribute because I know -2x plus 2x is no x. But what do I know? -2x plus 6y equal to -2. Make sure you hit all three pieces. That's a big thing that kids forget. They just do one or two things. And I'm going to copy this one down as it was. And then I'm just going to add. 6y minus y is 5y, or plus actually. -2 plus 7 is 5, and y is 1. And then I'm going to use that substitution property. And I kind of like this equation right here. That's what I'm going to go for. X minus 3 times a 1 is a 1. X minus 3 is 1. X is 4. Don't forget about your ordered pair. The ordered pair was 4, 1. And it has a single solution. I believe this says to classify. That is consistent independent. There you go. ACT style question about these. For what value of A would the following system of equations have an infinite number of solutions? They will have the same number of solutions. So that infinite number there. This happens if both equations are the same. All right? If both equations are the same. So what I'm going to do is I'm going to put both EQs into y equals mx plus b form. So let's start with that one. We've got 2x minus y equals 8. I'm going to shift this over. Negative y is negative 2x plus 8. And I'm going to divide out that negativity. So y is 2x minus 8. And I'm going to do the same thing with the other one. 6x minus 3y is 4a's. I'll worry about what a is in a minute. Negative 3y equals negative 6x plus 4a. I shifted my x's over. I'm going to divide out that negative 3. Y is 2x. Notice those match. Minus 4/3 of a. This is what I need to be true. I need these to match. Because I want these things to be the same. So negative 4/3 of a must equal negative 8. Let's just go ahead and multiply by 3 on both sides to clear the fraction. That a is on the level. Let me rewrite that. I didn't put that a in the right spot. Negative 4/3 a, it's on the level. 3 both sides, negative 4a is negative 24. Divide out the negative 4, and a is 6. So choice B. It's a mid-level ACT question. Sketch the graph of the set of all points that solve each system of linear inequalities. I don't consider this to be a hard skill, but that's me. So this is what we call a compound inequality. It says two things. It says x is greater than 0, and it says x is less than or equal to 125. Now, you know that x equals a constant is a vertical line. Greater than 0, I'm going to be dashing. 125, let me take more second out. Let's do by 5s. Maybe I can get, that would be 25. 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100, 105, 110, 115, 120, 125. And that is a solid line. Check that. 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100, 105, 110, 115, 100. Yep, put it in the right spot. Bigger than 0 and less than 125. It's asking me to shade everything in between. I want a bigger shader here. Let's undo some of my work here. Oh, too much. It's supposed to be to the left of that 125 and to the right of 0. I'm supposed to be shading all this junk. All right, now let's look at this one. That says 2y is greater than or equal to x, and I wrote that inequality wrong. Forgive me. It says 2y is less than or equal to x, and 2y is greater than 0. Both of these we're going to have to divide the 2 out. So y is less than or equal to 1/2 x, and y is greater than 0. Greater than 0 is the easiest thing to graph. Remember, y equals a constant horizontal line. It's going to be the x-axis. And I'm supposed to be bigger than that, so I'm going to be shading above. 1/2 x, we think mx plus b. So we cross at the origin, and then we rise 1 and run 2. Now I've gridded out on 5s. So it's not quite as easy. But if I was to run 10, I would actually rise 5. I also need to work with this equation too, because I need to set the y-axis. So let me do that first. 2x plus 2y less than or equal to 300. 2y less than or equal to negative 2x plus 300. And y is less than or equal to negative x plus 150. Okay, so I need to go up 150 units. So I'm going to count by 5s here. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100, 105, 110, 115, 120, 125, 130, 135, 140, 150. All right, so since I'm counting by 5s on both the x, y axis, I can just rise 1 and run 2. Rise 1, run 2. And I'm going to do lots of points because I need this thing to be as straight as possible. You know, I just finished grading the test y'all took yesterday or Thursday, and y'all can't keep things straight. I told you when I taught this lesson about graphing that you put down lots of dots because you won't be able to keep it straight. And turns out you can't keep things straight. Your generation just can't do that, can you? There's a joke in there somewhere. Anyways, this was less than or equal to. That's why I did a solid line. It's also telling me to shade below. So I have this guy saying shade up, this guy saying shade below. I'm shading all that stuff inside that triangle. And the last thing I'm supposed to do is I'm supposed to graph this negative x plus 150. It crosses at 150, and then it falls 1 and runs 1 because the slope is negative 1. And I'm just going to fall 1 and run 1. Do lots of dots. Otherwise, I'll miss it. should be crossing right there. And it is a less than equal to, it's saying shade beneath me. And what I end up with is this overlap space right here. A little four-sided quadrilateral in there. And that is where everything is happy. That is the answer to this thing. All right? Everything is happy in that shaded region. Last one. Yes. Instead of triangular tiles, triangular and square tiles contain 50 pieces and 170 sides. So we got some T's and some square tiles, and together there's 50 of them. T plus S is 50. Now we talk about 170 sides. You know, I don't know how dense you are, but a triangle has 3 sides. And a square has 4 sides. So now I can write another equation that would say 3t plus 4s is 170. And ta-da! I have a system of equations. So what is Milbrath going to do? He's going to multiply the top by a -3. And I'm going to multiply the bottom. I'm just going to leave the bottom alone because I have additive inverses. -150 and 170 is 20. -3s plus 4s is s. And there's t's are gone. So I have 20 squares. Now remember that triangles plus squares was 50. If I take away the 20, I have 30 triangles. 20 squares, 30 triangles. That's it. And there's your homework for 1-5 that Milbrath gave you on a Friday because he loves you. Right? Exactly.